In this video, we'll be talking about inequalities. And inequalities says that one expression is greater than, and this is the symbol for greater than or equal to, and this is the symbol for greater than or equal to, less than, and this is the symbol for less than, or less than or equal to, and this is the symbol for less than or equal to another expression. Let's talk a little bit about properties of inequalities. Note that when a less than symbol is shown in these notes, you can substitute greater than or equal to, or less than or equal to. This should be greater than. Our first property says that if A is less than B, then A plus C is less than B plus C. In other words, if you start with an inequality and you add the same quantity to both sides, then it'll still be the same inequality symbol. The second property says that if you start with an inequality and you multiply both sides by some number which is greater than 0, in other words positive, then it'll stay the same inequality symbol. Now this one's a little bit different. The third property says if A is less than B and C is negative, C is less than 0, then A times C is greater than B times C. In other words, you started out with a less than symbol, and then when you multiply both sides by a negative number, you then have to change that to a greater than. So you have to switch those inequality symbols. So that's very important to remember. Always reverse the direction of the inequality symbol when you multiply or divide by a negative number. A linear inequality is an inequality that can be written as ax plus b is greater than 0. Notice that the degree of the variable x is 1. It's a first degree inequality. So let's do a problem. The problem that we'll be doing will solve negative 2x plus 7 is less than negative 5. So just like when we have an equation, we want to isolate the variable. So we would like to get this 7 off of here. And we'll do that by subtracting 7 from both sides. The positive 7 and the negative 7 will cancel. And I have negative 2x is less than, and then negative 7 plus negative 5 is negative 12. The next thing that we'll want to do is get the coefficient of x to be equal to 1. So since this is a negative 2 times x, I'm going to divide both sides by negative 2. Then negative 2 divided by negative 2 is 1. These will cancel. And I have x on the left side. Now, don't forget, when you multiply or divide by a negative number, like we did here, we have to switch the direction of the inequality. So originally it was less than, so we need to make that greater than. And then negative 12 divided by negative 2 is 6. In the next video, we'll look at different ways that we can express this solution set. This is one way. If we wanted to use set notation, we could say the set of all x such that x is greater than 6. If we wanted to use interval notation, we want all numbers that are greater than 6, but we don't want to include the 6. So when you don't want to include the endpoint, you use parentheses, open parentheses. And this is my left boundary. So 6 is my left boundary. And then I'm going to go all the way up to positive infinity. That'll be my right boundary. Since there is no number at positive infinity, I need to use the closed parentheses on that one. And then we could also graph our solution set. The graph for x is greater than 6. We have a one-dimensional number line, and let's make this point 6. And I don't want to include the 6, so I'm going to use parentheses, but I want points that are greater than 6. So we'll darken in that number line to the right of 6, and then show the arrow. Now notice if I had less than here, I would make my parentheses go the other direction. Let's solve another one. There's a number of ways to approach this problem. I'm noticing that my denominator here is just a single constant. So one way to do this is to break this fraction up into two terms. I think I'll do it that way. So I could have 2x over negative 8. That's this one. And then plus, and then negative 5 over negative 8 is a positive 5/8. And then let me copy the right side. Another way would be to multiply both sides of the inequality by negative 8. Get rid of that denominator. So let's do some simplifying here. This 2 over negative 8 is the same as a negative 1/4 x. And then I have plus 5/8 is less than or equal to 1 minus x. Now let's put our x's on the left, so I'm going to add x to both sides. These will cancel, and a negative 1/4 x and a positive 1x is 3/4 x. And then copy the rest of my inequality. Subtract 5/8 from both sides. And these will cancel. I have 3/4 x is less than or equal to, now 1 is the same as 8/8. Subtract 5/8, that'll leave me with 3/8. And then I want to get this coefficient to equal 1. I'll do that by multiplying both sides by the reciprocal, 4/3. So this cancels, and I have x is less than or equal to, see, the 3's cancel, and then 4 divides both of these, and I have 1/2. So x is less than or equal to 1/2. Let me show you this inequality the other way as well. If I start with 2x minus 5 over negative 8 is less than or equal to 1 minus x. This time I'm going to multiply both sides by negative 8. So on the left side, the negative 8's cancel, and I just have 2x minus 5. And don't forget, when you multiply or divide by a negative number, you have to change the direction of the inequality. So originally it was less than or equal to. I need to change that to greater than or equal to. And then when I distribute, negative 8 times 1 is negative 8. and negative 8 times negative x is a positive 8x. Now let me move my x's to the right side. So let's subtract 2x from both sides. These will cancel, and I have negative 5 is greater than or equal to negative 8, and then 8x minus 2x is 6x. Let's add 8 to both sides. These will cancel. A negative 5 and a positive 8 is 3. And then on the right side I have 6x. Divide both sides by 6. 6 over 6 is 1, so I have an x on the right side, and 3 divided by 6 is 1/2. Now to see if these two are the same inequality, I'd like to write my x on the left. So when I turn this inequality around and I put my x on the left and my 1/2 on the right, I need to turn my inequality as well. Notice that the sharp point is on the side toward the x, so when I turn that around, it now is pointing toward the x. And so these two inequalities are identical.